On 7.3, we have different similarity theorems. So we've seen before this side, 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 and the side, angle, side in congruence theorems, proving triangles congruent. But it works for similarity as well with regard to proportion. So for the first theorem, this says angle, angle similarity. So in triangles, if all three angles are the same, then they are similar. The reason that this theorem only has two angles, it's angle, angle, is because if two angles are the same, so right here this 57 is the same as angle D, and then the 78 is the same, then the third angle is automatically going to be the same because they all add to 180 and you're just subtracting the same thing out. So no matter what, that third angle will be the same. So it's unnecessary to put that third A in there. That's why it's just angle, angle. So if two angles are the same, the third's automatically the same, which means they're similar. So that is angle, angle similarity. Side, side, side similarity means that the sides are similar, not congruent. That means they're in the same ratio. So for side, 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 all three sides have to have the same ratio when you divide the fraction. So I start with the smallest all the time, so first side I take as the smallest side. So in this case, 10 is the smallest and 12 is the smallest. So I'm going to write that as a fraction, 10 over 12, and that reduces to 5/6. So that is good. That one works, and then we're going to try the second side and see if that one is also similar, if it has the same fraction basically as the other one. So side number 2, I'll just do the middle side. 12 is the next smallest, and then 14.4. So 12, if you divide them over 14.4, this is a little harder to reduce. But if you put that in your calculator, you get the same repeating decimal that you get when you divide 5 by 6. So those are also the same. And then you can't just assume the third side is similar. It doesn't work like that with side, side, side. So you actually have to do it. So this third side is 15 and 18. So if I divide 15 over 18, if you reduce each of those by 3, you still get 5/6. So all sides are the same proportion, which means that side, side, side similarity proves that these two triangles are in fact similar. Put that similarity sign in between them if you want. And then there's side, angle, side similarity. So two sides and the included angle. It has to be the angle in the middle. The included angle has to be equal. So in this case, if we're looking at the 57 that's in the middle, 57 is congruent to 57, so that middle angle is the same, and then we want the corresponding sides to also be the same ratio. So again, I'll go with the smallest side first. 10 and 12 are the smallest. So if I do 10 over 12, that is the same as 5/6. Then I'm going to pick a less obnoxious color. And we want the other side, 15 and 18. And if you start with the left triangle, you have to start with that one every time. So 15 over 18, those both reduce by 3, 5/6 is used a lot today, apparently. And 5/6 works for that side as well. So that is when you can prove similarity with side-side-side theorem.